Good evening and welcome everyone. Hello guys. Welcome to GMAT Word Problems in the Layer of Logic. Can you hear me clearly? Excellent. Excellent. Thanks for that. Nice. I see quite a few familiar names already. Good stuff. Excellent. All right. So let's get into it. Before we get into the questions, real quick, in case you guys are meeting me for the first time, hello, my name is Anish Pasi. Quick background, I won't take a lot of time, but I'm an engineer and an MBA. I did my software engineering from McMaster University, Canada. I pursued my MBA from Ahmedabad after working for a few years. I've worked in different industries over the years. I have been a GMAT trainer since 2012. I appeared for these tests, CAT and GMAT, while I was preparing for applying for MBA schools myself. And then I quite enjoyed it. I was pretty good at it. I was good at test taking. I enjoyed the tests. So I started teaching after I graduated. In fact, while I was a second year student of my MBA, I was taking CAT coaching classes in Ahmedabad also. So I've been into education in some form or the other for over 10 years now. Before I started the GMAT Co and got into GMAT coaching full time, I was the director of a company called Neo Stencil and Test Cafe before that, both startups in the edtech space. I am a GMAT coach, but I like to think of myself as a GMAT learner. Just that I'm someone who's been on the journey for a lot longer than most of you guys have. And as a consequence, there are a lot of things that I've picked up along the way. And because it's my bread and butter, I've focused in depth into a lot of those things also. But yeah, I'm learning along the way as well, right? So even for today's session and in general, I always say, don't take my word for anything. Don't just accept something just because I told you so. And in fact, that's true for everyone. Don't just take anyone's word for it. Don't just accept something because you read it at the back of a book, because you read it online somewhere, because heard of it in a video. Accept it only if things make sense. I'll ask you to apply the same test today as well. All right. Our agenda, pretty straightforward. We'll get into a bunch of official questions, right? Word problems specifically. So we'll deal with concepts such as time, speed, distance, work rate, mixtures, and things like that. Right. Let's see how much we get done. Overall, I will ask you guys, given that it's a pretty big group, I will ask you guys to keep the discussion focused on the specific question at hand, right? It's very easy for the discussion to go into tangential directions, right? So I'm sure you might have questions related to your own GMAT prep. Some of you might have questions related to our upcoming GMAT intensive course. You might have other questions also. But at least for the duration of this session, at least while we're dealing with questions, I'll ask you to keep the questions focused on the specific question and nothing else, right? We will take out some time towards the end for a short Q&A in the end, right? So if you have any questions like that, hold on to those till the end. Overall, I anticipate the session will go on for about 2 hours. It might run over a little bit over as well. Let's see how it goes. All right, before we get into questions, one question, just so we don't dive into questions right away, and also I get to know at least a little bit about you guys. If you could just let me know in the chat window where you guys are from. If you feel the city is enough, that's fine. Need the state, country, whatever. Okay, excellent. I'm from Noida also, by the way. All right, so I saw a couple of people from Noida. Nigeria, interesting. Welcome. All right, quite a few from NCR region. Shamli, Uttar Pradesh. Got it. Good stuff. Hi, Akshay. I am well. Hey, Raghav. Good to see you. I know, of course. I remember you. Good stuff. Excellent. Canada. Hi, Kashka. Haha. Wow, Sydney. So we will be covering wide range of time zones. What time is it for you in Sydney, Satyapal? Oh, good to see the hope. I don't put you to sleep over the next 2 hours. All right, excellent. Welcome, everyone. Glad to have you all here. Very interesting to see the wide range of time zones we're covering. Hi, Kiran. Okay, let's get into it. So, how we'll deal with each question. And by the way, those of you who have taken courses with me before, we are dealing with all new questions, right? At least you wouldn't have come across these questions with me in one of the sessions. Now, how we'll go about each question is that I'll give you, I don't know, close to 3 minutes initially to answer it, to go through it yourself, and then we'll get into answering. While I am explaining the solution, at that point, I'll ask you to hold on to your questions if you have any, because it's very much possible that you might have a question and I address it in the course of my explaining the solution, right? Once I'm done with the question, I will ask you guys if you have any questions. I might also in between ask you, right? So, but let me lead that, right? If you have any questions, don't ask on your own. I will give you opportunities to ask questions. Again, I don't guarantee that I'll be able to answer all of your questions in this 2 hour window, but I'll try. Let's see how it goes. All right, then, let's get into it. Here's your first question. Go ahead. I'll give you 10 seconds more. All right. If you're still trying but couldn't get to an answer, select the sixth option. Okay. All right. I'll end the poll here. Interesting. Okay. All right. Let's go through the question again together. A boy walking along a road at 3 kilometers per hour is overtaken by a truck traveling at 40 kilometers per hour. Overtaken by a truck? So that tells me that the boy is walking on the road at whatever his speed is, and then the truck comes from behind, right? The truck comes from behind, traveling in the same direction as the boy, and then overtakes the boy. All right. And their speeds are given. Of course, the truck is faster. All right. If the truck breaks down 1 kilometer beyond where it passes the boy. If the truck breaks down 1 kilometer beyond where it passes. So the truck comes from behind, the boy is walking, truck comes from behind. From the point where it passes the boy, it carries on traveling for 1 kilometer and then it breaks down. Okay. How many minutes after the breakdown does the boy reach the truck? How many minutes after the breakdown? What does that mean after the breakdown? That we're not looking at time from the point when the truck passed the boy. We are looking at time from the point when the truck had already broken down. That's when the clock starts, right? Truck breaks down, the clock starts. Now, how many minutes will the boy take to reach the truck? That's what we have to figure out here. Okay. So we'll discuss two different approaches to get to the answer here. That will be the common theme for most questions we'll deal with today. For most questions, we'll discuss multiple approaches. All right. So what's going on here? Let's say point A is the overtake point. That's where the truck initially passes the boy, right? And then point B is the breakdown point where after 1 kilometer, the truck breaks down. All right. Now, what's the time taken by the truck to travel the 1 kilometer? Well, its speed is 40 kilometers per hour. So 1 kilometer would be 1 by 40 hours, right? The truck takes 1 by 40 hours to reach point B. And then in that time, how much distance does the boy travel in that time? Basically, the boy, by the time the truck reaches point B, the boy would no longer be at point A. The boy is also walking for that much time. So the boy would have reached somewhere over here, right? So that distance is 3 by 40 kilometers. In those 1 by 40 hours, the boy would have traveled some distance. It's not like he was waiting at point A while the truck continued moving. Okay, so 3 by 40, then what? How much distance is left now? Well, the boy needs to travel a total of 1 kilometer. Of that 1 kilometer, he's already traveled 3 by 40. So what's left is 37 by 40. That much distance now the boy needs to travel. We know his speed, 3 kilometers per hour. That will help us figure out how long he'll take, right? So distance upon speed, 37 upon 40 upon 3 gives me the time. 37 upon 40 times 3, hours. This is in hours. The question is how many minutes after the breakdown, right? So I convert the hours into minutes and I get 37 by 2, which is nothing but 18 and a half. Why is the last option? There we go. The answer is E. Not B, not B, which actually was the most common answer. And why you guys would have got B, I'm guessing, is because you did not take this portion into account. How many minutes after the breakdown does the boy reach the truck? Right? The boy takes 20 minutes to travel 1 kilometer, but he's been already traveling for some time. So actually, if you think about it, without any of these calculations, I could have understood initially itself that the answer has to be less than 20 minutes. Why is that? Because to get from point A to point B, overall the boy takes 20 minutes, and the boy would have been walking while the truck got from point A to point B also. Right? For that duration, the boy would have been walking as well. So anyway, the answer would be less than 20 minutes, because for the remainder portion, the boy would take something less than 20 minutes. On that basis alone, actually, we could just eliminate these two options. We would still need to go through this to calculate, but then at least 20 should not have been our answer. All right, I'll discuss one more way to get to the answer here, and then in case you guys have any questions, we'll take them up. Same question. Now, before we get into any sort of solving any equations, let's just understand what's happening. What time do we need to figure out? So the truck passes the boy. After passing, the truck travels for 1 kilometer, breaks down. While the truck is traveling that 1 kilometer, the boy is walking also, right? From the point when the truck broke down, now how much longer will the boy take to reach the breakdown point? That's what we have to figure out. How did we get 20 minutes? What was 20 minutes? Basically the time from the passing point to the breakdown point. To cover that entire 1 kilometer, how long will the boy take? Now, how long had the boy been walking already? Well, as long as the truck took to reach from point A to point B. That's how long the boy had been walking already, right? For the entire distance of 1 kilometer, the boy would have taken certain time. Of that time, how long had the boy been walking already? The duration that the truck took to reach from point A to point B. For that duration, the boy had been walking already before we start noting the time. So we can use this understanding directly to get to our answer also. What I mean is, basically we know their speeds. Now, how long does the boy take to reach from point A to point B overall to cover this 1 kilometer? His speed is 3 kilometers per hour, right? We'll use that. And then we'll also figure out how long does the truck take to reach from point A to point B. And then since what we care about is how many minutes after the breakdown, what I'll do is from the time the boy takes to travel the entire distance, I will subtract the time that he'd been walking already. How much time had he been walking already? The time it took the truck to reach the other point, which is nothing but 0.2 here. So basically what I'll do is 1 minus 2. Now, what's the time taken by the boy to reach A to B? 3 kilometers in 1 hour. 1 hour, that's his speed. So 1 kilometer in terms of minutes will be how much? 1 kilometer in 20 minutes, right? And then for the truck, it's 40 kilometers in 60 minutes. So 1 kilometer in how long? 60 by 40 or 1.5 minutes. So what's the remaining time? 20 minutes minus 1.5 minutes. That's 18.5. That's option E. We could get to the answer this way also. Okay. One thing which we use quite frequently in our sessions also, AC, UC, all clear, unclear. So first let me know, whatever we discussed here, is that clear or is there some aspect which is still unclear? Cool. All right. I don't see any use. Ah, there we go. Okay, go ahead, Abdul. Let me know. Abdul, is it okay if I call you Abdul, or tell me what aspect is unclear? And while you type in, meanwhile, let me know, where do you think you guys faltered? Where do you think you faltered? Because option E was marked only by 23% of you. So where do you think the rest of you faltered? I think so too, Jagdish. Okay, Karan. But I initially also said that I'll give you 3 minutes anyway. And I actually gave you a lot more. No, so there shouldn't be that pressure. And that's unnecessary pressure on yourself then. And that's very not that's very common, right? The distance covered by the boy and the truck were not given. 1 kilometer beyond where it passes the boy. That's where the truck breaks down. We're given that distance. If the truck breaks down 1 kilometer beyond where it passes. Don't worry about that, Apar. Huh. That's a that's a common issue. Don't worry about that. I'll not get into that right now. But at least for this session, don't worry about what you need to do on the exam. At least for this session. Chalo, Abdul, I'm not very clear on what aspect you're unsure of. Let's take it up in the end, huh, if there's still something. But what I understood was you mentioned that distance is not given. The distance is given. All right. Chalo. Let's move on to the next one then. All right, 5 seconds more. And yeah, let's follow the same thing. If you still couldn't get to your answer, select the sixth option. Okay, all right. I'll end the poll here. All right, let's go through the question together now. Jerry and Jim run a race of 2000 meters. First, Jerry gives Jim a start of 200 meters. What does this mean? Jerry gives Jim a start of 200 meters. So Jerry's like, Jim, you go ahead, you take a lead, right? You cover some distance even before the race starts. You reach that 200-meter mark, and then we'll start the race. So basically, when the race will start, you'll be at the 200-meter mark, I'll be at the 0-meter mark. And we both need to reach the 2000-meter mark. Right, so Jerry has given Jim a head start, some advantage. Jerry gives Jim a start of 200 meters and beats him by 30 seconds. So who beats whom? Who beats whom? What are we given here? And beats him by 30 seconds. So Jerry beats Jim by 30 seconds, right? Despite giving Jim an opportunity, or despite giving Jim a head start, Jerry still beats him. All right, that's one aspect. Beats him by 30 seconds. Hold on. Beats him by some time? What does that even mean? Initially, Jerry gave Jim a start in terms of meters. Okay, that is easy to understand. But then he beat him by 30 seconds. What does that mean? 30 seconds, right? He beat him by 30 seconds time? How do we make sense out of this? Unless this is clear, it doesn't make sense to move on to the next statement. Beats him by 30 seconds. What does that mean? So what this means is that wherever Jim is, wherever the slower guy is, when the faster guy reaches the end point, wherever the slower guy is, from that point to reach the ending point, the slower guy would have still taken 30 seconds more. The slower guy would have still taken 30 seconds more, right? Jim required 30 seconds more to reach the end. And Jerry had already reached the end point by then. That's what beats him by 30 seconds means, right? Jim would have required 30 seconds more to reach the end point. Okay. So that's what's happening first. Next, Jerry gives Jim a start of 3 minutes. Okay. Separate situation, it seems. Jerry gives Jim, again, Jerry was the faster one. The faster guy gives the slower guy a start of 3 minutes. Start of 3 minutes, what does that mean? That, all right, it's 7 o'clock right now. You start running, and then I will start running at 7:03. That's what Jerry perhaps told Jim, right? You carry on running for 3 minutes. I'll wait here. And once 3 minutes are done, then I'll start running. So Jerry gives Jim a start of 3 minutes and is beaten by 1,000 meters, and it's beaten. Oh, so this time Jerry loses. This time the slower guy actually reaches the end point before the faster guy. And in fact, he is beaten by 1,000 meters. So at the time when the slower guy reaches the end point, at that time, the faster guy is only at the 1,000 meters mark. How did this happen? How come the faster guy is behind? Because of the 3 minutes head start. 3 minutes, it seems, was too much of a head start, right? It was so much of a head start that then the faster guy could not catch up, at least not within the 2 kilometers race. All right. Find the time in minutes in which Jerry and Jim can run the race separately. All right, so I have to look for two figures. The time it takes for Jerry, the faster guy, to run the race, and time it takes Jim, the slower guy, to run the race. And in fact, I can notice that in the answer choices also. All in each answer choice, the first figure is smaller than the second figure. Again, indicating that Jerry is the faster guy. Right? One guy takes, for example, let's say option A, 8 minutes, and the other guy takes 10 minutes to run the same race. So of course, the second guy would be slower. Now, it's not written, but one thing we can directly apply, understand and apply is that Jerry and Jim would have maintained the same speed in all these races. Had their speeds changed, then anyway, the question wouldn't make sense, right? So whatever Jerry's speed was in the first race, whatever his speed was in the second situation, whatever his speed was, would be if he runs separately, they would all be the same. Similarly, Jim's speed throughout will be the same. Not written, but that much we can directly understand. All right, now that we get the question, let's try to simplify it before we get into solving. So what have we discussed so far? Basically, in the first situation, when Jerry gives Jim a start of 200 meters and beats him by 30 seconds. So by the point, the faster guy reaches the end point. Faster guy, Jerry. And the faster guy reaches the end point. At that point, the slower guy, who's Jim, is behind. How much behind? 30 seconds. Right? Jim would have taken 30 seconds to cover this distance. That's what we know. Okay. In the other situation, who reaches the endpoint first? The slower guy reaches the endpoint first. At that point, where is the faster guy? Where is Jerry? He's at the 1,000 meters mark, right? He's covered 1,000 meters, or there's 1,000 meters left. Since it's a 2,000 meter race, he's at the midpoint. Now, one thing, I'll use these things interchangeably. I might use the name Jim, or I might refer to him as the slower guy. And similarly, I might refer to the other person as with his name, Jerry, or with the phrase faster guy. Right. So I hope that doesn't confuse you. All right. Now what? Again, we'll discuss two different approaches. First, let's consider an algebraic approach. Let me take some variables. What variables should I take? Well, I'm already given some information about the distances. I'm given some information about the times. So it makes sense to take variables for their speeds. All right. So let me assume Jerry's speed is f meters per minute. F for the faster guy. Meters per minute. Why did I take meters per minute? Because that's what we're dealing with, right? All the distances are in meters, and all the times, well, most of the times are in minutes, and eventually I need to figure out the answer in minutes also. So instead of first assuming meters per second and then converting in the end, let me just start with meters per minute. There's one figure in seconds, but that's 30 seconds. I can easily convert that into minutes. All right. So let's assume Jerry's speed is f meters per minute. Jim's speed is s meters per minute, right? The slower guy. All right. What then? Now I'm thinking in the time the faster guy runs the 2,000 meters, the entire race. In that much time, how much distance does the slower guy run? In the time the faster guy runs 2,000 meters, how much distance does the slower guy run? How can we figure this out? Now, let's understand. Let's say this is the entire track, 2,000 meters, right? Start and finish. How much distance was run by the slower guy in the time that the faster guy finished the entire race? So what happened initially? Initially, the faster guy is waiting. He's like, you go ahead, you reach the 200 meter mark, and then I'll start. So anyway, I will not count this distance of 200 meters, right? That much distance was run even before the actual race started. I won't count that. What else? By the time Jerry reached the end, Jim had reached some point in the middle. What point? a point from where he would have taken 30 seconds more to reach the end point. So how much distance did the slower guy run? Well, whatever is left in the middle, right? The entire track was 2000 meters. Of those 2000 meters, I'll subtract the 200 meters, right? That much was run even before the race started. I will also subtract this distance. How much is this distance? Well, we've taken a variable for a speed. So speed into time will give me the distance. So minus s times 1 by 2. That's the distance that the slower guy will run in the time the faster guy finishes the entire race. Okay. Now, this is one piece of information that I'll keep separate. I'll use it later. All right. Now, what's going on in the second situation? In the second situation, again, what are we dealing with? What I'm saying here, let's be very clear about this. In the time the faster guy runs 1000 meters. So what's happening? Jerry gives Jim a start of 3 meters and is beaten by 1000 meters. So Jerry's first like, you go ahead, run for 3 meters, then I'll 3 minutes, then I'll start. And then when he starts, he's only able to run for 1000 meters. And by that point, Jim has reached the ending. So in this duration, in which the faster guy runs 1000 meters, in that duration, while the faster guy is running, parallelly the slower guy is also running. How much distance would the slower guy have run? He already had a head start of 3 minutes. So from the entire distance of 2 kilometers, I will subtract the head start because he was able to reach the end point. So that's why I'll count the entire distance of 2 kilometers, right? So the slower guy from the entire 2000 meters he was able to reach the end point, and he already had a head start of 3 minutes. So from 2000 meters, I will subtract this head start distance. That will give me the distance that the slower guy would have run while the faster guy covered 1000 meters. What would that be? 2000 minus this distance. What is this distance? Well, 3 minutes, and his speed is again s meters per minute. So 2000 minus 3s. What's 3s? The head start, basically. 3 minutes times the speed, that's the head start. And then 2000 is the distance for the entire track. 2000 minus the head start. That's how much distance the slower guy would have run in the time it would have taken the faster guy to run 1000 meters. Vartika SK, is the second situation clear to you guys? Okay, Vartika, then maybe we'll discuss in the end. Or maybe you can go through the video again. Huh? All right. So why am I dealing with these? Because one thing I noticed initially, that in the second race, the faster guy is running 1000 meters. That's a very interesting figure. That's the middle point, right? So I wanted to use that. I wanted to use that characteristic, that he'll reach the middle point. He's only able to reach the middle point in the second race. Now, tell me, how would these times compare? What are the times? The time the faster guy takes to run 2000 meters, how would that time compare with the time the same guy takes to run 1000 meters? How would these two times compare? What do you think? How would these two times compare? One time is twice the other. One time is twice the other. Okay, right? To cover 2000 meters, he'll take double the time of what he'll take to run 1000 meters. Now, as a consequence, how much distance will the slower guy cover in the time? This time is twice, right? 2 times the time. And here the time is half. So correspondingly, the slower guy in the first situation will cover double the distance compared with how much distance he's covering in half the time, right? Since the time is getting halved, correspondingly, the distance run by the slower guy in that much time will also be half. So what I can do now is basically I can say that this A, 2000 minus 200 is 1800. 1800 minus half S equals 2 times 2000 minus 3S. What I have basically done is A equals 2 times B. How did I get there? By first realizing that the faster guy would take double the time to cover 2000 meters compared with 1000 meters. And in twice the time, the slower guy would run twice the distance compared with how much he runs in half the time. So that's how I get this equation. 1800 minus half S equals 2 times 2000 minus 3S. Now it's a matter of solving this equation, right? I go about solving it. I take the S's on one side and everything. I eventually get the speed S is equal to 400 meters per minute. That's the speed of the slower guy. So in terms of minutes, how long will the slower guy take to cover the entire race? It's a 2000 meters race. So it's running 400 meters per minute. He'll take, for 2000 meters, he'll take 5 minutes. I could go on to calculate the speed for the other guy also, but I glance at the options and I realize if the slower guy is taking 5 minutes, actually option A, C, D, and E are all wrong. Right? He's not taking 10, 9, or 10 minutes. He's taking 5 minutes. So anyway, all the other options are wrong. And that already tells me that the answer is B. Of course, the key here was to set up this whole thing, right? How to think about, oh, I could set up this way to consider how much distance is the slower guy running in both cases and compare that, right? Once I set it up, then it was a matter of just solving the equations. But then the key was actually realizing this is how we could set it up, right? For me, how I got to thinking like this was by understanding that in one case, the faster guy is running 2000 meters, in the other, he's running 1000 meters. I use that to my advantage. We'll discuss one more approach, and then if you have any questions, we'll take them up. All right, same question. Let's consider another approach. Now, before anything else, just by looking at the first situation, Jerry gives Jim a start of some distance and still beats him by 30 seconds. That already tells us that Jerry is faster, right? Jerry is faster. That much, I hope, is clear to everyone, right? Jerry is faster. He's giving a head start to the other guy and still he's able to beat the other guy. So he's certainly faster. Now, based on just that, one thing we can directly realize is that in the time, the faster guy covers 1000 meters. In whatever that time is, in the time the faster guy covers 1000 meters, correspondingly, how much distance will the slower guy cover? More than 1000, equal to 1000, or less than 1000 meters? In the time Jerry covers 1000 meters, Jim will cover less than 1000 meters. Indeed. Right? Because Jim is slower, Jerry is faster. Okay. Why is this relevant? Well, I'm looking at the second scenario. in which we are given that Jerry gives Jim a start of 3 minutes. Right? Jim gets a start of 3 minutes and is beaten by Jerry gives Jim a start of 3 minutes, and then Jerry is beaten by 1000 meters. Now, let's understand. Start point, end point. Let's say we're talking about Jim and Jerry here, right? So the slower guy had been running for 3 minutes. He reached a certain point, right? I've shown that in the figure. In 3 minutes, he reached that point, wherever that point is. We don't know yet. And then afterwards, he covered the remaining distance. Now, in the time that Jim covered the remaining distance, in that much time, how much distance had Jerry run? When the race basically started, when both of them were running, from that point till the time when when the slower guy reached the end point, how much distance had Jerry run? 1000 meters. Exactly. Right? The slower guy had covered 1000 meters. So tell me, based on just this much, from this point till the end, how much would this distance be? More than, less than, equal to 1000 meters? Can we comment? This distance would be less than 1000 meters, right? Because this both happened in the same time frame. And of course, the faster guy would cover more distance. The faster guy is covering 1000 meters. So the slower guy would cover less than 1000 meters. Now, one more thing, the entire track is 2000 meters. Of that track, in the first 3 minutes, the slower guy had already covered the first leg, right? One portion he had already covered and one portion was left. How much was left? 1000, less than 1000 meters. So how much would he have covered in the 3 minutes? In the first 3 minutes, he would have covered more than 1000 meters. All right, this is quite interesting now. What I started off to do was, I started off to get an estimate of roughly what the times might be like. So that's what I'm still trying to do. The slower guy would have covered more than 1000 meters in 3 minutes. The slower guy would have covered more than 1000 meters in 3 minutes. Based on just this piece of information, how much distance, or rather, how much time would the slower guy take to cover 2000 meters? For 2000 meters, Jim would take how long? I don't need an exact figure, but can we get any estimate? Let me ask you this way. Yeah. Compared with 6 minutes, where would he be? Would he take equal to 6 minutes, more than 6 minutes, or less than 6 minutes to cover 2000 meters? He would take less than 6 minutes. Why? Because he's covering more than 1000 meters in 3 minutes. So in 6 minutes, he'll cover more than 2000 meters. In other words, to cover 2000 meters, he would take less than 6 minutes. Just this much. Now, if I go through the answer choices, well, Jim's figure has to be less than 6. I scan the options. There's only one answer choice that matches. So that's the right answer. And we are done. We're actually done already. Was it lucky that the answer choices worked out this way? Well, maybe. But then I didn't tweak the answer choices. These are original official questions answer choices, right? Worst case, I'm sure we could have eliminated at least 2 or 3 options, if not all. But also remember that our foremost objective, in case you guys are wondering, yeah, but what if there were other options that were less than 6 also? realize our foremost objective is to answer the question on the screen. That's our foremost objective. And we'll try to do that in the most efficient way that we can. After that, we can think about variations and everything. But if instead of answering the specific question on the screen, we are thinking, okay, forget about the options. Let me just answer the question, assuming the options could change in the future also. Then we are not doing the justice to the question. Then we're not using the resources that are there at our disposal. Right? So, and in fact, if you recall, even in the first approach that we discussed, there also we did the same thing. There also we figured out 5, and then I scanned the options and I eliminated all the options that weren't equal to 5 for the second guy. So it's not like we didn't use the options there, right? So options are a part of our resources. It's absolutely fine to use them. All right. ACUC, where do we stand? No, Jesse, that's not what the initial portion means. Jerry gives Jim a start of 200 meters. So that's the first thing that's happening. Jerry's like, Jim, you go ahead. You start from that 200-meter mark. I'll start from this point. And then there's a gunshot. Then the race starts. Now the race has started. Now, by the time Jerry reaches the end point, he's first. He beats the other guy. Not just that, he beats him by 30 seconds. So the other guy, to cover the remaining distance, the other guy would have taken 30 seconds, right? So there's actually no direct relation between the first 200 meters and the 30 seconds that he would have taken in the end. Cool. All right. Let's move on. I asked very few ACs though. What's going on? Was this too heavy? What was it? Huh? What about the rest of you? Tell me, how's the session going so far? Are things making sense? Kirtan, I'll not look into that right now. Could there be other ways to solve the question? Sure. Right. So I'm definitely not saying these are the only ways to get to the answer. Hana, so I'll not be able to evaluate that right now. Okay, let's carry on. All right, here's the next one. Okay, I'll end the poll here. Quick comment, Kirtana, no. Answer to your question, no. Because you're missing out about the bit of the first 200 meters, right? So there would be some time for that also. All right, getting into this question. Working alone, printers X, Y, and Z can do a certain printing job consisting of a large number of pages in 12, 15, and 18 hours respectively. All right. So who's the fastest, by the way? Who's the fastest? X, Y, and Z can do a certain printing job in 12, 15, and 18 hours. X is the fastest. He takes the fewest hours, right? X is able to finish the job in 12 hours. Z is the slowest. Z alone takes 18 hours. Okay. What is the ratio of the time it takes printer X to do the job working alone at its rate? Ratio of what? Time it takes for the printer X to do the job working alone, which is 12 hours, to the time it takes printers Y and Z to do the job working together at their individual rates. Okay, so what do we need to figure out here? We need to figure out a ratio. What ratio? Time taken by X alone to finish the job is to time taken by Y and Z working together to finish the same job. We have to figure out this ratio. All right, how do we go about it? So one way is we can apply the work formula directly to figure out how long it would take Y and Z to finish the task working together. Basically, 1 upon the time taken by Y working alone plus 1 upon the time taken by Z working alone equals 1 upon the time taken by both two machines working together. Right? I solve this. 1 by t equals whatever LCM, and then 15 plus 18. Overall, t equals, I would need to take a reciprocal, 5 times 18 over 11. I cancelled 1, 3. Right? 5 times 18 or 90 over 11. It's t. What's t? Basically the time. And everything is in hours. So this is 90 over 11 hours. That's how long the this shouldn't be X and Y. This should have been Y and Z. My bad there. That's how long the two would take working together. What do we need to figure out? The ratio of 12 hours is to this ratio, 90 by 11 hours. Right, now it's a matter of just canceling the common factors, cross multiplying and everything. Right, I'm able to cancel a 6, so I get 2 is to 15 by 11. I take the 11 on the other side. I get 22 is to 15. So the answer here is option D, not C, by the way, which is the second most common answer. Of course, the mistake that you would have made would have been you did not take a reciprocal, or you took an incorrect reciprocal somewhere. But then it's a bigger mistake than that. And I'll discuss that. The answer is D, right? What did I do here? Figured out the time the two machines would have taken together using this formula, the standard work formula. And then I just figured out the ratio. All right. How else could we answer this question? How else could we answer this question? Now, this is one approach I discuss with my students also. I call it the sum common multiple. Sum common multiple. Instead of LCM specifically, the idea is that we can just take any common multiple, whichever one we find easy. Common multiple of what? Of the hours. So 12, 15 and 18 basically, mainly these two figures, because those are the machines that would go on to work together. Right? So let me think of some common multiple of these numbers. The multiple that came to my mind was 180. Right? 15 times 2, 30. Then I was thinking of multiples of 30. And then I was thinking of easy multiples of 18. I was able to come up with 180. Now, why deal with this? So now I'm going to say, let's assume that the total work is 180 units. 180 units. Here, let me give you a quick background about the concept of work. Basically, printers X, Y, and Z can do a certain printing job. Now, whatever that printing job may be, it could be printing 180 pages, it could be printing 1800 pages, one page, whatever, right? Whatever that job is, it takes the machines 12, 15, and 18 hours respectively. So I can assume that work to be some units that actually help me with calculations, right? So I would want a figure that's a multiple of these so that when I need to divide by the hours, I don't deal with any fractions. I can directly just get integer values and my life will be easy. We'll see that in action. So let's say the total work is 180 units. What does units mean? Some units, I don't know. It could be number of pages, it could be number of binders, whatever it is. I don't really care. As long as it's the same for everyone, it's fair. There's nothing wrong here. Now, let's say the total work is 180 units. The second machine, Y, does 180 over 15, 12 units per hour, right? The total work is 180. Y alone takes 15 hours. So per hour, Y takes 12. Y does 12 units per hour. Similarly, Z does 180 over 18, 10 units per hour. Now, together, how many units per hour would these two guys do? Would these two machines do? One machine does 12 units per hour. The other does 10 units per hour. Together, how many units would they do per hour? How do we figure this out? 22, yes. Basically, all we need to do is add them up. Why is that? Again, it's important that we understand work from a very real world perspective. Let's just take a detour quickly to understand. Let's say two people are painting walls. So what would be happening? One guy is painting his walls, and parallelly in the same time, the other guy is painting his walls. And together, how many walls would they have painted in 1 hour? Well, as many walls as the first guy painted, plus as many walls as the second guy painted, right? So when it comes to work, we can directly add up rates. Why? Because that's how work works, right? Here also, one printer is printing and parallelly the other printer is printing. Let's say one printer is able to print 12 units in an hour. The other is able to do 10 units. Together, they would have done 22 units in an hour. Right? This is not a mathematical concept. We can just understand this. That's how work works. Together, they would have done 22 units per hour. So in order to finish off 180 units, how long would they have taken? For 180 units, Y and Z together would take 180 divided by 22 hours. That's the time. Now what we need to figure out is the ratio. So ratio of X's time remains 12 hours only. I don't need to actually worry about X, do anything with X, right? Because end of the day, what I need to figure out is the ratio of the times. So I already have X's time of 12 hours. That remains as it is. And now for the other two machines, their combined time is 18 by 22. Again, it's a matter of canceling out the factors and everything. Eventually, we get the same ratio again. 22 is to 15. That's the second approach. I'll discuss one more approach here. And then in case you guys still have any questions, we'll discuss. All right. Now, before we get into any calculations, before we get into any equations, any formulae, anything like that, and one reason is because realize a very big percentage of you guys marked C as the answer. And why that would have happened, I'm guessing, but I think why that would have happened is because you either misinterpreted the formula or you made some calculation error in terms of reciprocals and everything somewhere. So before we even get into all those things, let's understand a little bit more about work. First, what I need to figure out is how much time Y and Z together would take to finish the job. How much time would Y and Z together take? What I'm given is that Y and Z take 15 hours and 18 hours respectively. Just to get some idea of roughly how much time they'll take. Let me start off with saying that let's say both these guys take 12 hours each. Right? Let's say Y and Z each takes 12 hours to finish the task working alone. Let's say alone. Now, if these two people who together who take 18 hours each, or these two machines, sorry, these two printers which take 18 hours each got together, in how much time would they be able to finish the job working together? Each machine takes 18 hours. How much time would they take to finish off the job working together? They would take 9 hours. Half the time. Why half the time? Because in half the time, the first machine would have done half the job, and parallelly, in the same time, the other machine would have done the other half. So combined, they would have finished the work. If the two machines would have taken 18 hours each, working alone to finish the job, together they would have taken 9 hours. Now, why am I dealing with this? I'm dealing with this to get some idea of what the time taken would be for these two machines working together. Okay, what do I do now? Actually, in our question, Y is taking 15 hours, not 18. Right? One machine is taking 15 hours instead of 18. So if one machine is taking 15 hours instead of 18, would these two machines, one machine taking 15 hours, one machine taking 18 hours, would these two machines take more, less, or equal to 9 hours? Can we comment? Two machines that would have taken 18 hours each would have taken 9 hours. Now what have I done? I've replaced one machine with a faster machine. Right? A 15-hour machine would mean it's a faster machine. So by replacing with a faster machine, now they would take less time. Right? So Y and Z together would take less than 9 hours. This much I can realize just by figuring this much out. In fact, let me not stop there. Let me take it further. What if each of them took 15 hours, let's say? Then how long would they take to finish off the work, working together? 7.5 hours, right? Yep. Given that in our situation, one machine actually takes 18 hours and not 15. What can we say? Would their total time be more, less, or equal to 7.5 hours? It would be more than 7.5 hours. Indeed. So what's the ratio that we're looking for? We are looking for a ratio which is 12 is to something between 7.5 and 9. 12 is to something between 7.5 and 9. Let me scan the options. 4 by 11, gone. 1 by 2, gone. 15 by 22, gone. Now, let me compare the remaining two options. 11 by 4, 12 by 4 would have been 3. 11 by 4 is 2 point something, more than 2, right? Would this ratio be more than 2? No. 12 is to 6 would have been 2. This is 12 is to something bigger than 6. So definitely this ratio is less than 2. That also helps me eliminate the last option. And I get my answer. All right. Tell me, ACUC. Cool, cool, cool. I don't see any U's yet. That's a good sign. All right. Let's carry on. Chalo, let's start with this. We'll see. All right, I'll end the poll here. Cool. All right. When a certain tree was first planted, it was 4 feet tall, and the height of the tree increased by a constant amount each year for the next 6 years. increased by a constant amount. What does this phrase mean? Increased by a constant amount. So was the increase the same percentage every year, or in terms of feet, was it the same? What was constant each year in terms of feet, right? Yeah. So let's say whatever, in 1 year, let's say the growth was 2 feet. So every year the growth was 2 feet. It's not percentage. And anyway, initially there's a height of the tree, 4 feet, and then there's an increment that's happening every year for 6 years. At the end of the 6th year, the tree was 1/5 taller than it was at the end of the 4th year. At the end of the 6th year, okay, it was 1/5 taller than it was at the end of 4th year. So 2 years before, 1/5 taller. So whatever its height was at the end of the 4th year, plus 1/5 of that height. That's how much the height became at the end of the 6th year. By how many feet did the height of the tree increase each year? Okay. We'll discuss two approaches here, right? What we are told is that 1/5 of year 4 should be equal. Basically, one way to understand this is that 1/5 of the height at the end of year 4. 1/5 of the height at the end of year 4 is how much the growth was in the last 2 years. Right? At the end of the 6th year, the tree was 1/5 tall. So whatever the height was at the end of the 4th year, year 1, year 2, year 3, year 4, year 5, year 6, whatever this height was, how much was the growth from that point? This growth was nothing but 1/5 of the height at the end of that year, at the end of the 4th year. Right? So 1/5 of this much was actually added on top. We can think of it that way. And that's how we got to the end of the 6th year. Okay. So one way is we could try the options also, right? This is just to highlight how we can actually use options as well. So by how many feet did the height of the tree increase each year? Indeed, these are the answer choices of feet per year, the growth in terms of feet per year. So even if, let's say, nothing else tracks us, let's start with the very first option, 3/10. What do we need to do here? On one side, I'll figure out how much was the height at the end of the 4th year. How much would be the height at the end of the 4th year? Well, the initial height is 4 feet plus 4 times this answer choice, whichever answer choice I'm dealing with. Right? So let's say 3/10. So 4 feet plus 4 times 3/10. That would be the height at the end of the 4th year. And then 1/5 of that, 1/5 of this would be equal to how much? The growth in the last 2 years. How much was the growth in the last 2 years? 2 times the same answer choice. So whichever option shows that the LHS is equal to RHS would be the right answer. So that's one way. Let's get into it. Right? First option is 1/5 of 4 plus 4 times 3/10 equal to 2 times 3/10. Well, if I notice, 4 times 3/10 is 12/10. 4 plus something a little bit more than 1. Overall, this bracket is greater than 5. And then that divided by 5, overall, LHS is greater than 1. And the right side is 2 times 3/10. 6/10 is definitely less than 1. Right? So, no. Here, the left side is not equal to right side. A can't be the answer. I won't calculate the exact value. I'm getting a rough estimate and I can notice that already it's wrong. Let's try the second one. Is 1/5 of, let me just clear this, 4 plus 4 times 2/5 equal to 2 times 2/5. Now, again, what do I notice inside? Well, 4 times 2 by 5, 8 by 5 plus 4. Again, LHS is more than 1. RHS is less than 1. So left hand side can't be equal to the right side. This one is gone also. Third one, 1 by 5 times 4 plus 2. This is 2. 4 plus 2, 6 by 5. Left hand side is 6 by 5. Right hand side is 1. Not equal. Next one is 1 by 5 times 4 plus 8 by 3 equal to 4 by 3. I could calculate, but I've been able to eliminate 3 options already. This one, I can't eliminate right away. Right? I'm not very sure. Let me park it aside. I'll come back to it. Let me look at if I can eliminate the last one or actually calculate the last one easily. Then I'll come back to D. So what's going on in the last one? 1 by 5 times 4 plus 4 times 6 by 5. That's the left side. Is that equal to 2 times 6 by 5? That's what I have to figure out. Now, one thing I notice here, if I multiply by 1 by 5 inside the bracket, I get 4 by 5 plus 4 times 6, 24 by 25. That's the left hand side. 4 by 5 less than 1, 24 by 5 less than 1. I'm adding up two numbers which are less than 1. Will I get something which is greater than 1? No. 2 times 6 by 5, 2 times something greater than 1 is more than 2. I'm adding up two terms which are less than 1 each. My sum overall will not be more than 2. So E is wrong also. This should read E. And that already confirms that D is the answer. I could, to be more certain, calculate it also. But then just because I've been able to eliminate the others, that also leads me to understand D will be correct. So what we did here was we started off with the answer choices and checked which one fits. Of course, we could go the algebraic way here as well. Right? That perhaps was a very clean way to deal with this question. The idea in algebra is to understand what the equation should be. Right? So that's why in words, the problem needs to be clear first. What's the problem here? Again, that 1/5, basically I'll use the same statement here to create an equation. 1/5 of year 4's height should be equal to the growth in 2 years. Right? I'll use that to create an equation. Growth in feet is the same every year. Growth in years 5 and 6 is basically 2 times the growth per year. And that's equal to 1/5 the height at the end of year 4. Now, let's say the growth per year, what we need to figure out is X feet. Let's say. What would be the height at the end of the 4th year? Well, 4 feet initially plus 4x plus x plus x plus x plus x for every year. So 4 feet plus 4x. That would be the height at the end of the 4th year. What would be the growth in the last 2 years? X plus x, 2x. Now, 1/5 of the height at the end of the 4th year. 1/5 of that is equal to 2x. Now it's a matter of solving for x. I get x equals 2 by 3. Most of you did have that answer also. So yeah, that's indeed correct. AC, you see any questions here? Okay. How do we decide? Is there ambiguity in the question, Isha? When a certain tree was first planted, when it was planted, it was 4 feet tall. And the height increased by a constant amount each year for the next 6 years. So when it was planted, it was already 4 feet tall. The increase in the first year wasn't 4 feet. Will it be given? I think, Isha, it's already clear in the question. No, it's not like there's any ambiguity. All right. Yeah, let's do this one. All right. I'll end the poll here. Hmm. Interesting. All right. Material A costs $3 per kilogram and material B costs $5 per kilogram. If 10 kilograms of material K consists of X kilograms of material A and Y kilograms of material B, is X greater than Y? A lot of variables going on in the question. There's A, B, there's K, there's X, Y, right? But then A and X are linked. X is the weight of material A. Y is the weight of material B. So there are two materials and then their weights. What are we given? That the two materials, they're added up to form a 10 kilograms result, right? That's called K here, right? These two raw materials are added up to create a 10 kilograms mixture, let's just call it. The question is, in that 10 kilograms mixture, is the quantity, is the weight of material A more than the weight of material B? Is the weight more or not? That's the question. Do we need to calculate the exact weights? No. All we care about is the weight more? Is X greater than Y? Is the number of kilograms of material A more than the number of kilograms of material B? That's the question. All right. Right? It's a yes, no question. I don't care about the exact values of the weights. I care about, is the weight more or not? Okay. X and Y are the weights combined. They add up to 10 kilograms. So each one of them must be less than 10, less than equal to 10, right? I mean, assuming that it's possible that one of them is not even there. And both of them should be more than 0, greater than or equal to 0, right? They can't be negative. The weights can't be negative. These are all the constraints there are on X and Y, right? They both, neither of them can be more than 10 and neither of them can be less than 0. Okay, any other constraints on X and Y? No, that's it. Now, before I get into solving, before I get into evaluating the answer choices, one thing came to my mind and I'll share with you also. What I thought of was, what would happen if the two were mixed in an equal quantity? What would happen if in the 10 kg mixture, X and Y were equal? In other words, 5 kgs each. Then how much would the overall mixture cost? What do you think? If X and Y were equal, 10 kgs would cost how much? $40. Right. Right. 5 times 3 plus 5 times 4. That's one way to think about it. Sorry, 5 times 5. So 15 plus 25, 40. Together, the mixture would cost $40 if they were in equal quantity each, equal weight. This is something that I thought about before heading into the statements. So I'm sharing with you also. All right, now let's get into the statements. The first one is saying Y is greater than 4. What did we have to figure out? Is X greater than Y or not? So Y greater than 4? Anyway, Y and X have to be less than 10. So if Y is 6, for example, correspondingly, X would become 4. Is X greater than Y? No. In this case, X is not greater than Y. That's sorted. But is it a certainty that X will be less than Y only? Do X and Y have to be integers? There's nothing like that given in the question. There's nothing like that given, right? X and Y are weights, so they can't be negative, and they add up to 10 kg, so they can't be more than 10. But then why can't we have decimal weights? There's nothing like that mentioned here, right? So if Y were 4.5, let's say, which is more than 4, in that case, X would be 5.5. And here is X greater than Y? Yes. As far as the question is concerned, just by learning that Y is greater than 4, I don't get a fixed answer, right? The situation I'm in is, well, maybe yes, maybe no. Therefore, statement 1 alone is not sufficient. Statement 1 alone is not sufficient. Now let's look at the second statement. The cost of the 10 kilograms of material K is less than 40. So 10 kilograms of K costs less than $40. And we had already discussed earlier that if X and Y were equal, if they were each 5 kgs each, the two materials, then the cost would be $40. Now, since the cost is actually lower, since the cost is actually lower, there'd be more of the cheaper material or the costlier material? What do you think? Had the two quantities been equal, then the cost would have been $40. Here, the cost is actually less than $40. So, which material would be more, the cheaper one or the costlier one? The cheaper one. Yeah, the cheaper one would be more. Which is the cheaper one? Material A. The corresponding weight is X. So this actually tells me that X is greater than Y. And therefore, the answer to this question is B, not C. C and B were tied to be the most common answers. Those of you who marked C, specifically you guys first, is it clear why the second statement alone is sufficient now? And everyone in general, anyone still unclear why the second statement alone is sufficient? So what was it? I'd like to understand. How come many of you moved on to C and in fact some of you marked E also? How come you decided that the second statement wasn't sufficient alone? See, this question is not just for me, but also for yourself. Right? This is where your analysis needs to happen, and that's where learning will happen. This is where I faltered. This is what I didn't understand earlier. That's what I should focus on in the future.